Okay, question 11. Diagram shows a course for a jet ski race. Actually looks like one of those bad guys from Masters of the Universe a little bit, if anyone's seen that. But anyway. The course is indicated by ABC and the length is 1.5 kilometers. B is 600. So again, classic. Most of the information is already here. The only piece of information that isn't actually shown on the diagram is a total length. Okay, so we know that's 650. We know that's 600. So that's, pardon me, that's 1,000. So that's 1,250. The full course is 1,500. So taking it away, we know this is going to be 250. That's the only thing they've not really shown us. Okay. Determine whether B is due east of A. Okay, now that's really just a fancy way of saying, is this a right angle triangle? Okay, that's really what the question is asking. If B is due east of A, and this is north, that's going to be a right angle, isn't it? So whenever you see bearing questions like this, you should be thinking about right angles and a question like this. This is the converse of Pythagoras. Okay, so if that was east, we would have a right angle triangle. Okay, so the mistake a lot of people make is to instantly go in and say, okay, well, in that case, a squared plus b squared is c squared, and we can't actually do that. Okay, what we need to do is separate it. Okay, so what I like to do is say left hand side, right hand side, and don't mention Pythagoras until the very end. So let's say 600 squared plus 250 squared on the left hand side, and on the right hand side, we're going to have 650 squared. Okay, so 600 squared plus 250 squared, that's going to give me, okay, that gives me 400, pen back, 422,500. And on the right hand side, 650 squared, that gives me 422,500. So we can say left hand side equals the right hand side. Therefore, by the converse of Pythagoras, obviously your handwriting should be significantly nearer than me, the triangle is a right angle triangle. I'll just say RAT for short. Therefore, B is due east of A. Okay, now maybe they need to state that, but I think it's always good. Just this is the way I would practice doing these questions. So we proved it's a right angle triangle, and because of that, B is due east of A. I think that's a perfectly valid, um, perfectly valid conclusion. But we need to make sure we have this left hand side and this right hand side. We don't say a squared plus b squared is c squared because we don't actually know that. Okay, so in terms of marks, you're going to get a mark for finding your 250. You're going to get a mark for evaluating this part. So that would be a mark, let's see, yeah, a mark for doing your evaluating. So that would be a mark here at this point. And then for actually explicitly stating that the theorem works, so we've said left hand side is right hand side, and then your final answer for given a valid reason. Okay, so big thing is here, don't write a squared is a squared plus b squared is c squared. Make sure we have a separate working to make it really make it watertight. We could have put an extra line in here to say, 422 500 equals, but I think saying left hand side equals right hand side is totally fine. But so on to the next question. So we've got circles, sectors, okay, two different radiuses. This is the important word here, mathematically similar. Okay. And as always, they've shown most of the information. The only bit they've not shown is that the area of the larger sector is 2750. Okay, so we'll just leave that. So basically, we just need to look at these two diagrams. So calculate the area of the smaller sector. Okay, so we define, we'll call this x then. So we're thinking mathematically similar. We are thinking of scale factor. Okay, so scale factor is always equal to new over old. Okay, new over old. Again, excuse the handwriting. I'm still getting used to this pen. Early days on the pen. So new over old. So the new is going to be the shape we're looking for, and old is the shape that we've got all the data for. Okay, so this is going to be our new shape over here. Okay, so the scale factor is going to have to be 30 divided by 50. Okay, 30 divided by 50. So we can reduce that, and we'll call that 3 over 5 just by cancelling the zeros out. Now I like to leave it as a fraction. Okay, it's nice and accurate. If you wanted, you could write down 0.6. That'd be the same thing for that one. That's totally fine. But sometimes this pops up in the non-calculator paper, and I quite like just leaving it as a fraction. Okay, so I'm going to be using this. Okay, so 3/5 is our scale factor, our linear scale factor. So just at the top here, I'm going to say linear scale factor. Now we can get area scale factor and a volume scale factor. Okay, so the area scale factor is actually equal to the linear scale factor squared. Okay, and the volume scale factor is the linear scale factor cubed. Now again, that's nice and easy to remember because area, square area, squared area, and volume is measured in centimeters cubed or whatever. So we've got cubed with volume and squared with area. The thing to remember is it's the linear scale factor we're doing this to. Some people would square the area scale factor to get to volume. No, it's the linear scale factor squared to get to area, and then the linear scale factor cubed to get to volume. Okay, so we know what our scale factor is, and we obviously want to work out our area scale factor, so we're going to square it. Okay, so area scale factor is equal to 0.6 squared. Okay, now if I times that by the original area, 2750, and then I'm going to get the new area of the smaller shape. Okay, I'll just get rid of this bit here. The area scale factor. Okay, so I can put that as a separate line, work out the area scale factor. We'll just do it in one big step. Okay, so on our calculator, that's going to give us 990. Okay, 990, and units centimeter squared. Okay, so marks for this one. The very first point is working out your linear scale factor. Okay, the second point is this stage here. Now again, actually I've put it down to 3 over 5. Could have just left it as 30 over 50. I think it's good practice just to do this because it might come up in a non-calc paper. And again, I'm just trying to highlight about decimals as well. I've thrown a few extra things just to make you think. Obviously, there's no need to do that in the actual question. But yeah, your linear scale factor squared times by your area, so that's your other mark, and then the final answer is your third mark. Okay. Question B, calculate the size of angle ACB. Okay, so I want to know what this angle in here is. Now again, we're dealing with circles. A few equations should kind of jump to our head, but there's a few at the beginning in the formula sheet. Let's see what we've got: triangles, spheres, cones. Well, actually, no, you get nothing for circles. So it needs to already come from your head. Okay. So when you think circles, I'd be thinking, okay, well, I know circumference. That's pi d. Okay. We're looking for an angle, so nothing in there. Area. I know the area is pi r squared. Now that's quite handy because we actually do know area and we do know r. That's good, but we're not looking at full circles, we're looking at sectors. So the area for a sector is actually the same as the pi r squared, isn't it? But it's multiplied by theta divided by 360. Yeah, because it's the portion of the circle. Okay, it's the circle area times the ratio of the angle you've got to all the angles in the circle. Okay, So this looks good to me. This will be our equation. Okay, so area is equal to pi r squared times theta over 360. Now the question is asking us to find theta, so that's cool. And let's just substitute and see if we've got everything. So the area of the big section is 2750, and that's equal to pi times the radius, which is 50 squared, times our theta, which we're trying to find, divided by 360. So it's looking good to me then. So we know everything except for theta. So yeah, I'd be looking at that and thinking, okay, I'm on to a winner. I know what I'm doing. But we obviously need to rearrange it first. Okay, so we could work out everything then rearrange it, but I'll just rearrange it first. Okay, so to get rid of 360, we're going to have to multiply. So we're going to do 2750 times 360 because we're dividing on this side. So we're going to multiply. And then on this side, we're doing pi times 50 squared times this. So to get rid of this, we'll just divide it. Okay, because we're multiplying it on this side, so we'll divide it on the other side. Okay, so divide by pi times 50 squared is equal to theta. Okay, so this side we multiplied up, and here divided down, doing the opposite of what's on that side. Okay, so if we work through that, we should end up with an angle of 126 degrees. Okay, now just check it doesn't say, that doesn't say to decimal places. You could go more two decimal places is probably quite good, but I'm just going to leave it there. Okay, so yeah. Okay, and the marking scheme for that one has got us with a mark for expressing it. Yep, so this would be our first mark in here. Second mark would be rearranging it for theta, and then the third mark obviously solving it. Okay, but yeah, it's quite a nice little question that actually. I think for similar shapes, this is quite a straightforward question. That's probably the hardest thing to remember with similar shapes. People always get confused with this. So the only thing we never touched on was going back the way. Don't forget the linear scale factor is the cube root of the volume scale factor. So say that probably the most difficult thing about this is when they give you a volume scale factor and ask you to work an area scale factor. That's one of the harder questions. And to do that, you take your volume scale factor and cube root it to get back to your linear scale factor, and then square it up. A lot of folk just do the square root thinking it goes back one step, but it doesn't. You always need to go back to the linear scale factor and then up again. Okay, and likewise here, you square the linear scale factor, or you cube the linear scale factor. You don't square then square. Okay. Yeah.